Welcome everybody. I'm excited to be here at VeeamOn 2015 for this brown bag session, the stunning benefits of storage snapshots. Just to introduce myself, my name is Chris Vacanti. I'm a senior consultant with House of Brick Technologies from Omaha, Nebraska. Perhaps in today's organization, you're using storage snapshots. Maybe you've talked about using them, but you may still have a few questions about the process or the value of using storage-based snapshots in your environment. Throughout the conference here at VeeamOn, we've heard a lot about storage-based snapshots. So I want to take a little more of a deep dive approach into the benefits of using storage snapshots. I'll be using a case study from one of our clients and show the value that it brought to their backup processes. My case study, like I said, is based on the experience of one of our customers. They had a tier 1 application that was running with SQL Server on the back end. Users were reporting application lockups. These coincided, like I said, to the backup window. Again, it was hourly. What was happening is calls were coming into the help desk and a solution had to be found. So what do you do in this situation? How do you troubleshoot this? What kind of a solution would you come up with? Most companies, most organizations, leadership would take the knee-jerk approach and stop doing hourly backups so that the application was, again, useful to the organization. This is what happened. They removed the hourly backups, went to a once-a-night nightly backup, and House of Brick was brought in to help figure out a solution. Before we go into the technical back end of things, we just want to review what is the backup process that Veeam typically uses when it's taking a backup only using VMware-based snapshots. So the job will begin. Veeam will issue a command into VMware to have a VM snapshot created. Data is then pulled from the parent disks while the snapshot Delta file is growing. Once that data is copied out, the backup job through Veeam will then issue a remove snapshot command to VMware. The data from that Delta file is then written back into the parent disk. In a high I/O organization or with an application or a database with a lot of I/O, this can be a lengthy process. During that time, it's called a stun. The VM, when the data is being written back into the parent disk, can go through a pause or a stun. VM KB article 1002836 talks about VM stun time. You access this information by downloading the vmware.log file from the data store to a local machine, open it as a text file, and you'll want to search for the word stun. In this example from the VM KB article, you can see that this VM was stunned for 403 seconds. The initial data is recorded in microseconds. Our client, their situation was that the database server during the hourly backups was being stunned for 13 seconds. That translated to lockups, application timeouts, and pauses at the end user's desk, rendering the application unusable for the organization. So what we did is when we came on board, we took a look at the opportunity to leverage storage snapshots through Veeam. Veeam provides this help article about leveraging backups from storage snapshots. It is specifically designed to help eliminate stun time at the application or the VM layer. So how does that differ from a traditional VMware-based snapshot backup? So leveraging storage snapshots, the process is a little different. You still have a VM snapshot command issued through Veeam into VMware. Once the VM is snapshotted, Veeam will then, through the API of the storage layer, issue a snapshot command at the storage. Once that snapshot is created at the storage layer, Veeam immediately sends a release or a delete command to the VMware snapshot through the VMware interface. What this does is it means that in a high I/O organization, the swap file, or the delta file rather, for that Veeam during the snapshot for VMware, it doesn't grow very large. It's only there for a very short period of time. We've seen that snapshot be in place as low as 1 second, 2 seconds at the max. So after the data is, once the snapshot is released from the VMware side, Veeam will then go to the storage files, that snapshot, and pull that data back across the network, or depending on how you have your backups configured. Once it completes the backup, the storage snapshot is then deleted, and the backup job is completed. So some supporting data on our case study is this. You'll note that with no storage snapshot, again, the removal start time for the VMware snapshot was 2:47. That ended at 3:01. That VM was stunned for 13 seconds. Again, that's data we pulled out of the VMware.log file from the data store. When we put in a storage snapshot, we can see that the stun time was as low as 1.1 seconds. Is it a guarantee that it's going to be that low? No, it's not. Is this a best use case scenario for every environment? Not necessarily. Are there other caveats to the design of the data store, your storage, or your VMware environment that need to be taken into consideration? Absolutely. But hopefully, what you've been able to glean from all of this today is that leveraging storage-based snapshots can mitigate the effects of VMware stun time. We were able to then implement storage-based snapshots using a NetApp SAN in this client's environment, return to hourly backups so that the client could meet their SLA. I hope that gives you some information today that you're able to use, take it back to your organizations, and use that as a discussion point. Thank you for your time.